In this video, we present a simple Pong game in C++. The Pong game is a classic two-dimensional video game that acts like a digital table tennis. Two players move their vertical pedals up and down to hit a bouncing ball. If a player misses the ball, the other player gets a point. To do the animation, we can use the OpenGL utility function getVisibilityFun to register a visibility callback for the current window. We name the callback withHandle here. When the window's visibility state changes, Get immediately calls this function withHandle. Now, a window can be visible or not visible. It is Get visible when at least a portion of the window or its descendants is visible on the screen. It is Get not visible when none of the window is visible. For example, it is completely occluded or minimized. Okay. So this is the callback withHandle. Okay, we have a parameter visible. If it is visible, okay, then we call a function timer handle with parameter 0. Okay. Now the timer handle works like this. Okay. First, we use the Get utility function getTimerFun to register timer callback function, which will be executed once after some milliseconds. Okay. And the timer handle works like this. We have one parameter value here. It is the visibility callback. And within this function, we can call the animate function to change the state of the game. And then we display the state. And we use this function, getTimerFun, to call this function, call itself again, after 25 milliseconds. And with a parameter for value here, it is 0. And actually, it is not used in our example here. The following is a complete C++ program. The program is simple and straightforward. The x-coordinate is from -10 to 10, and y-coordinate is also from -10 to 10. It is defined by the GU of 2D. These are the game variables. So ball x is the x-coordinate of the ball. Ball y is the y-coordinate of the ball. And ball dx is the change in x of the ball. Ball dy is the change in y of the ball. YL is the left pedal position, and YR is the right pedal position. The pedals can only move along the y direction. PW is the pedal width, and PH is the pedal height. Score left is the score of the left player. Score right is the score for the right player. And we can pause the program by defining the Boolean variable pause. Initially, pause is false. That means we want to do the animation. Okay. Draw pedal is to draw a pedal. Okay. Draw this pedal using the GL red F. And draw string is to draw a string. Mainly, it is to display the scores at this position. And draw ball is to draw the ball. We use this utility function, cut solid sphere, to draw the ball. It is drawn at the origin, so we need to translate to the specified XY position. This is the initialization of the graphics. And this is to display the scene. This scene, the pedal, the ball, and the scores. Okay, so we draw the left pedal, and then draw the right pedal, and then draw the ball with different colors. And then we draw the score. We set ball is to start over. We set the ball at the center and reverse the ball direction in the X direction. Now this is the actual animation. This process true, then it returns. That means we don't want to do any animation. And we move the ball by increment X by ball dx. So ball dx could be positive or negative, and ball y the same thing, by increment by ball dy. And this is the top-bottom collision, and left pedal collision if it is within this range. Okay, then we have a collision, and then we reverses the ball direction in the X direction. This is the right pedal collision. Okay. And so if ball X is more than -10, that means the left player misses the ball. So the right player get a point. So we increment score right, and we start over again. Otherwise, if ball X is larger than 10, that means right player misses the ball. So the left player gain a point, and we start over. And this is a simple AI pedal. Which, when ball Y is larger than Y out, the position of the right pedal, then we increment it by a small amount. Otherwise, we decrement it. Okay, so this is the right pedal controlled by the simple AI algorithm. And then we display the scene. Okay. Now this is the keyboard. This escape is to exit. Press R is to reset. P is to pause. If it is paused, then it becomes true. Well, if it is paused, okay, then it becomes, if this is true, then it becomes false. Otherwise, it is true. Okay. That means the toggle is between pause and running. This is a special key callback function. It is used for the up arrow and down arrow movement. Okay. And this is the visibility callback we discussed. This is the vis handle we mentioned earlier. This is the main. So we use this, the got special fun to define the special key, mainly for the up and down arrow keys, okay, to move the pedals. Okay. The left pedal is controlled by the user. The right pedal is controlled by the AI. Okay. Now let's copy and compile and execute this program and see how it works. Copy and paste it into Pong.cpp. Okay, so this is our program, and we can compile it. -o Pong, the executable, the source, and we did link with the graphics libraries. So we get the executable Pong, so we can execute it. And the right side is the AI, and the left is humans. So we get Pong. So there's like a Pong. Okay, so the other side missed, so we get another Pong. So we got Pong. And we can pause it anytime and continue. So you can try this yourself. Okay. Finally, let's discuss how we can train a transformer to play the Pong game. We can use a decoder-only or GPT-style transformer. We discussed this before in this video, training an AI transformer to play tic-tac-toe in C++. If you're interested, you can refer to this video. So the approach is similar to what we did here. So we regard the game as a sequence of states and actions. And state Sn is associated with action An. So a token is a struct of S and A. So here the state consists of the coordinate of the ball, say ball x, ball y, and also the displacement of the ball dx, ball dy, and the positions of the left and right pedals, yl, yr. Okay? And the action is the movement of the pedal. So basically it is y is assigned a new value, y is equal to y plus delta y. Delta y could be positive or negative. So during inference, given a sequence S0, A0, S1, A1, blah, blah, up to Sn minus 1, An minus 1, the transformer predicts the next token consisting of state and action. There's Sn, An. Now, we can get the data in these ways. We present three methods here. And method one is to use a rule-based expert. So that's what we did in a simple game. So if the y coordinate of the ball is larger than the y coordinate of the pedal plus a constant d, positive constant d, okay, then delta y, the change in y, should be equal to a positive value d. Okay. Otherwise, if ball y is more than pedal y minus d, okay, then we should decrement y. So delta y is equal to a negative d. Otherwise, we just stay. So that means delta y equals 0. So there will be no change in y. So the action is basically delta y. So the new y will be equal to y plus delta y. The transformer learns to imitate the expert. Okay. So this is the simplest method and the recommended method. Another way to do this is to play the game by humans. We just play the game by humans and record sequences of state and action or token. Okay. And another method is to use reinforcement learning. In this case, the transformer interacts with the game and optimizes reverse. For example, we can award a positive one for the agent for hitting the ball and deduct a point for missing. Alternatively, we may use a decision transformer to play the game. So decision transformer is a causal transformer like GPT. The model's trajectories as a sequence of 3 tokens. So the 3 tokens are return, state, and action. We know what's a state, what's an action. A return is the cumulative reward the agent aims to achieve. For example, the score is the return. Say at a certain time, a certain instance, score is 9. We are at state 0, and delta y is d. That means the action is up. Okay, and at stage 1, so the return or the score is 9, and delta y is 0. So the action is to stay. Okay? And in this case, the return is 10. Okay? It is stage 2, and here delta y is negative d. That means we want to move the pedal down. Okay? During training, we can mask the tokens to so that the model only predicts the action tokens. So that's how we can train a decision transformer to play this game, okay, which may be more natural. Now, this wraps up our discussion on this topic. Okay. Thank you for watching, and I will see you in the next video. Thank you. Bye-bye.